This is a short review on central and inscribed angles. So we're going to start off with the idea of central angles and how they are equal to or congruent to their arcs. So our first problem is asking us to find the angle UXV. So UXV. Well, to find that central angle, we have to look at what do we know about our picture. Well, I can see that the arc SW is 72. And the arc SW being 72, its central angle would be the same. The central angle and its arc will always be congruent. That means if I'm trying to find the central angle UXV, you'll notice that when you stare at those two angles, they look like they're the same, and that's because they are. These two angles that we have here are called vertical angles, and vertical angles are always congruent. So therefore, if that's 72, angle UXV is 72. The next thing it's asking for us to do is to find the arc ST. So now they want us to find this arc right here, ST. Well, we don't have a vertical angle for that one to help us out. So instead, we're going to look at the segment UW. That segment goes through the center and touches each side of the circle as a straight line, which means it's a diameter. And a diameter breaks the circle up into two equal pieces. So this section right here, that whole purple arc would add up to 180 degrees. Well, I know this section is 72, and I know this section is 87. So if I want the section that's left over, ST, I just subtract them from 180. And when I do that, I find out that arc ST is 21. The next thing it's asking us to find is going to be arc UV. So starting at U and going to V. Well, I can do what I did before, and I can see that UW is a diameter, and this bottom half of the circle would have to be 180 degrees. I know this section is 72, so if I want to know what this arc is here, I subtract that from 72. Keep in mind that this 72 is the same degree as this arc here, UV. So UV plus whatever the red arc is should add up to 180. So 180 minus the 72 is 108 degrees. So this right here is going to be 108 degrees. The next thing it's asking us to find is angle WXV. So they want us to find angle WXV, this central angle. Now the central angle, we know its arc is WV, which is 108, so its central angle is also 108. The angles from the center to the arc are always the same. Central angle, arc. Now it's asking for a much bigger arc, a major arc. So I'm going to do a little erasing here so we clean up the picture. It's saying it wants us to find the arc for TVW. So I'm going to start at T. I'm going to go all the way to V, then to W, and it stops there. So I care about the degrees that make up that arc. Keep in mind this 87, the central angle, means that this 87 is right here, the arc of TU. Now I know all the pieces of this major arc. Starting at T, going to U, I'm going to need the 87, going from the U to V, 72, and then V to W, 108. If I add those three numbers up, 108, 87, and 72, we get 267 degrees. The last little question it's asking for is what is the arc for SU? So for that one, we can see starts here at S and we go all the way to U. So we're going to be adding two arcs. We're going to add the 21 degrees and the 87 degrees. Going to add that up. That's going to give us 108 degrees. And this has been reinforcing the idea that a central angle is the same as its arc. And also the idea of you can add two arcs together, and that's called the arc addition postulate, when you can add two together to find a much bigger arc. Okay, our next problem is still dealing with the idea of arcs and central angles. So the next one's asking us to solve for x and then find the central angle that they're looking for. So there's quite a few ways to figure this out, and it's up to you how your brain kind of recognizes it. So the way that it jumps out at me is that I notice I have this 103 degrees here. 103 degrees for this arc. Well, if I look at the other side, I notice that this arc EH is the exact same size. So if these two vertical angles are congruent, then these two arcs over here would be the same as the purple arc over here. So I can take this degree and this expression, add them together, and equal it to the 103. So 18x minus 2 plus 15 equals 103. Because these two arcs in green sum up to be the vertical angle for the purple arc. So now I can go ahead and solve this problem. I have a negative 2 and a plus 15. That's going to give me 13. Then I'm going to go ahead and minus the 13 over. And you get 90. Then we want to go ahead and divide both sides by 18 to find out what x is. So 90 divided by 18 is 5. So we've learned what x is. This is just one way to figure it out. There's other ways. You could find out what hg is. Once you know that, you could use 180 degrees to figure this out as well. There's a lot of different approaches. As long as you get 5, you probably did it right. The next thing it's asking us to do is to find the central angle D, I, and F. D, I, and F. Well, we're going to need to plug x into that expression so we can find out what DE is. So we're going to do that now. So 18 times 5 minus 2, we're using 5 because that's what x is, that's what we learned. 18 times 5 minus 2 is 88 degrees. So we know this is 88 degrees. Now we got to figure out what this is, arc EF. Well, there's a few ways to do it, but what jumps out at me is that this arc right here in purple is 103. And I can notice that EG is a diameter, which means from E all the way around to G is 180 degrees because it's a semicircle. So if I know the purple is 103 and the whole right side is supposed to be 108, if I subtract those, we get 77, and that 77 is that arc. So 77 plus 103 is 180, half of a circle. Now that I know the green arc and the blue arc, these two arcs combined together is going to be 88 plus 77 is 165. So I'm going to do a little erasing. So this arc right here is 165. So its central angle, DIF, is going to be 165. Okay, so this next problem is also dealing with arcs, addition, and central angles. So it's asking us to solve for x, but this time you're going to notice that they give us information at each arc, except this one right here, but they do give us information about it, it's just not written out. You'll notice this little symbol in the central angle, that's our 90-degree symbol, and since this is a central angle, it's in the center, its arc is also 90 degrees. Now we actually have something for each section of the circle. And they're asking us to solve for x. We're going to need to use all those sections. So we have to ask ourselves, well, how many degrees are in a circle? 360. So I'm going to take each piece, the 90 degrees, plus 8x, plus 21x minus 12, plus 10x plus 9, all four of those pieces are going to add up and equal 360 degrees. So you kind of have a little bit bigger of a problem now. We're going to make this equation a lot smaller. We're just going to combine the x's and then combine the constants. So I've got 8x, 21x, and 10x. So 21 plus 8 plus 10, we get 39x. Then I'm going to go ahead, I'm going to combine the 90, the minus 12, and the 9. So 90 minus 12 plus 9 is 87. That all equals that 360. I'm just going to solve that much smaller problem now. I'm going to go ahead and minus the 87 over. So 360 minus 87 is now 273. Those cancel out. We got 39x. We're going to go ahead and divide both sides by 39. So x equals 7. So when you are provided every piece of the circle, every arc, you can add them all up and set them equal to 360. So this next problem is going to focus on your knowledge of inscribed angles and their arcs and how it's related to central angles. So in this problem, you'll notice that they're asking us to find our central angle GEH. They want us to find this right here. But before we can do that, what we really need to find is this arc from G all the way to H. We actually need to find that first. Well, we have a inscribed angle starting at G, going all the way to F, and then back to H over there. That inscribed angle is 42. Well, 42 degrees, if we know the inscribed angle and we want to know the arc, we multiply it by 2. So we're going to get 84 degrees. Then, since we know that this arc that we have marked in red, GH, its central angle is the one that's marked in purple. And an arc and its central angle are always the same degree. To add in a little bit more knowledge that's very important for your test, keep in mind if you're ever provided the arc like 84 and you need to know the inscribed angle, you would have to divide it by 2. The inscribed angle is always, always, always smaller than the arc. The central angle is always the same as the arc. So we learned this was 84. So over here, I'm going to put a little cheat sheet for you that would be really important to memorize. Arc going to the inscribed angle, you need to divide by 2. If you have the inscribed angle going to the arc, you're timesing by 2. A central angle to an arc or an arc going to a central angle are always congruent. They're equal to each other. So keep that in mind. Really important tip. If you actually understand this concept, you can get a lot of questions right by knowing that idea. Keeping it straight in your head. Very important. So this next problem is going to reinforce those kind of concepts. So here, they're asking us to solve for x. But before we solve for x, we have to find a few other things to kind of get us there. So our ultimate goal is to figure out what this arc is. QR. If we can figure that out, we can figure out what x is. Therefore, if we need to know what this arc is, we want to know what its inscribed angle is right here. Well, that inscribed angle, you may notice, is part of a triangle SQR. And we all know how many degrees are in a triangle, 180 degrees. We know one angle, angle Q, is 73, but they didn't tell us what R is, but we can find it pretty easily. Over here, SQ, the arc SQ, has a degree of 116. Well, you'll notice that the arc is connected to the inscribed angle SRQ, which means if I take this number and divide it by 2, I'll know what angle R is. So 116 divided by 2 is 58 degrees. Now that I know that's 58 degrees, I know 2 out of my 3 angles for this triangle. If a triangle is 180 degrees, I'm just going to minus the 2 that I know, and I'll find out what the third angle is. So 180 minus 73 minus 58 is 49 degrees. That means this right here, angle S, that's 49 degrees. Now I'm one step closer to finding x. So keep in mind that this right here, this inscribed angle, RSQ, which is 49, if we want to know what its arc is, we should multiply the 49 by 2. So 49 times 2 is going to give us 98 degrees. Once again, your inscribed angle should get multiplied by 2 to find its arc. The arc is always double the size of the inscribed angle. Now that I know this arc is 98 degrees, and this expression 19x plus 3 goes to that arc, I can set them equal to each other because now we know they're the same. So I have 19x plus 3 equals 98, minus your 3 over to get 95. Then divide by 19. And we get 5 for our x. So this has really reinforced the idea. Notice how we used the idea that we knew the arc was 116, and when we divided it by 2, we found its inscribed angle. We used the property of how many degrees in a triangle, which we have done all year long. Once we knew what angle S was, we used that property of inscribed angles once again to go ahead and say, okay, 49 times 2 gets us this arc, 98. Now that I know the degree of that arc and the expression for that arc, I can set them equal to each other, and I can solve. All right, last problem. Dealing with arc measure on a clock. The clock shows the time as 6:50. What is the measure of the arc of the minute hand from 6:50 to 7:17? So currently our minute hand is at 6:50. And then it's going to go to 7:17. So it's going to go right here. We need to figure out how many degrees it goes from here to there. To do that, we first have to ask ourselves, how many degrees are in a circle? 360 degrees. Well, we can help figure out this problem by then asking ourselves, well, there's a bunch of numbers on this clock, 12 big ones actually. So I'm going to divide 360 by 12, and that's going to give me 30. That 30 is actually 30 degrees. So every time we go from one big number to the next big number, it's 30 degrees. So from 10 to 11, 30 degrees, 11 to 12, 30 degrees, and so on. But we have another little issue. We're really close to the answer. However, we're ending at 717. That's not on one of the nice big numbers. So we actually have to figure out how many degrees is from each little tick mark. Well, if there's 1, 2, 3, 4, 5 minutes between each large number, I'm going to take the 30 degrees and divide it by the 5 minutes. That's going to give me 6 degrees. So every minute is 6 degrees. So 6 degrees, 6 degrees. Now I'm just going to add up all these numbers. 30, 30, 30, 30, and 30, then plus 6, plus 6. Just going to add it all up. We're going to get 162 degrees from here all the way there, 162 degrees.